Hi, today we are going to look at our Bundle 1 review to prepare for tomorrow's bundle test. The first thing we're going to look at is our undefined terms in geometry. We have a point. We think of a point as a location, okay? So it is a location. It has no size or dimension. It is merely a specific location with no size or dimension. Okay. We use points to help us create lines. Lines are identified as a one-dimensional, and I know I speak way faster than I write, so that means there's no thickness, one-dimensional continuous extension. And by continuous, I mean it's infinite. It's going left and right or up and down or whatever direction it might be going forever. So continuous extension. And actually, I just misspelled continuous. Continuous extension. That goes both directions infinitely. Both directions, whichever directions it might be traveling, because remember it is straight. It doesn't curve. Both directions infinitely. I know that's me writing a lot. And then a plane. Plane's a little bit easier to describe. It is a flat 2D or two-dimensional surface that extends forever. So if you thought of it like a piece of paper, it would be a piece of paper that goes on forever and ever in every direction. That expands forever or extends forever. And you can say in all directions. I do apologize for my handwriting today. Now we're going to look at the two undefined terms in spherical geometry. So remember, spherical geometry, we're not looking at the flat 2D world anymore. We're thinking of things on a sphere. So when we talk about lines in spherical geometry, we are actually talking about a great circle. Okay, a line is considered a great circle on the sphere. Okay, so it still continues on and on forever, only meeting up with itself to continue on and on forever, to continue that so-called loop. Great circles do not have any parallel lines. They intersect with each other all the time on the plane. And in this case, a plane in spherical geometry is just a great sphere. It's the three-dimensional sphere that we observe everything on in spherical geometry. We discussed how when we take triangles or really any shape and we put them on a sphere from a 2D standpoint, we have to change or manipulate the angles and the size. And because of this, all objects in spherical geometry are larger than in Euclidean geometry. So all objects are larger than in Euclidean geometry. So for example, a triangle is 180 degrees in Euclidean geometry. However, if I were to try to put a triangle on a sphere, I would have to manipulate it in such a way to be able to flatten it on the sphere that all of the angles would expand to be greater than 180 degrees. Surprisingly, they'd be less than 540 though, because at that point they would start to form, well, a circle. So It is a great sphere, and all objects in spherical geometry are larger than in Euclidean geometry. Okay. Now, talking about logic, I know we looked at these undefined terms. Talking about logic, we have our statements here. These are the types of logic statements we've discussed. Symbolically, if we think of a conjunction, we think of it as P and this symbol, remember the arrow pointing up, and Q. And that symbol means and, so its written relationship is P and Q. Disjunction, here we have a situation where we say P or Q, and whenever we're talking about conjunctions, we need both of those things to be true, while here with the disjunction, only one of them needs to be true. Then we have our conditional statements. These are our if-then statements, and we write them as P2Q, but we would read that or explain that as if P, then Q. Okay, then Q. Same thing here with our inverse. Our inverse is going to be quite the opposite. It's going to be not P, then not Q. If not P, then not Q. Finally, we move a little bit away from this order of things, the P's and the Q's. Now we're talking about the converse, which basically says, to prove this, I'm going to move in reverse. So instead of saying if P, then Q, now we're going to say, well, if it's Q, then it has to be P. So if P, or if Q, sorry, then P. In the same way, we have the converse, which is the reverse order of the conditional. We have the contrapositive, which is the reverse of the inverse. So we would say, if not Q, then not P. Okay. If not Q, then not P. And then finally, our biconditional, bi meaning two conditions. So we write this as P, and I guess there's two symbols we could use. We can either use an arrow left and an arrow right, or we can use the double arrow. And when I said an arrow left or right, I also meant you could do it like this. You could say P, one this way, one this way. It's written both ways, and that's perfectly fine. But this arrow means that P, if and only if Q. And we need to be able to say that in reverse as well. Q, if and only if P. Okay? Q, if and only if P. So to look at that in practice, if we talk about logic and how we write the statements, here we are given a statement. If two angles form a linear pair, then they are supplementary. Okay, so two angles forming a linear pair, I want to think of that as my P, and then they are supplementary. Okay, the being supplementary is like my Q here. Okay, so I have my P value, I have my Q. In a conditional, it's if P, then Q. In an inverse situation, I would use my no words. I would use my negatives. So I would say if, and then my P, not P. So if two angles do not form a linear pair, do not form a linear pair, there is my P, then they are not supplementary. This is where my Q comes into play. We can say they are not supplementary. And from that statement, we can determine if it's true or false. If they're not a linear pair, And I just realized I accidentally wrote linear, but I forgot to write pair. Sorry, right there. If they do not form a linear pair, then they are not supplementary. Linear pairs have to be side by side in the angle group, so there could be supplementary angles. So this would actually be a false statement. Our conditional, if two angles form a linear pair, then they are supplementary, is a true statement because linear pairs are supplementary. The converse, so now we're saying it in reverse. If they are supplementary, so if two angles are supplementary, then, and now we're talking about P again because it's if Q then P, then they form a linear pair. And we know that this is not necessarily true because we can have angles that are supplementary that are not a linear pair. So this would also be false. Now, it is possible that a linear pair is formed by two angles that are supplementary, but that's not what forms linear pairs. Contrapositive, so I'm saying if two angles are not supplementary, that's the thing you have to pay attention to. Then they are not, or then they do not form a linear pair. They do not form a linear pair. Then finally, if we read thinking about logic and how we use logic, determine if the conjecture below are true or false, and if false, we're going to give a counterexample. So the difference, so we're subtracting, between two odd numbers is always an odd number. So what they're saying is if I pick any two odd numbers and subtract them, it will always be an odd number. So let's do just that. We're going to pick any two odd numbers and we're going to subtract them. So I'm going to say 7 minus 3. 7 minus 3. Those are odd numbers. And when I subtract them, I get 4, which is an even number. So this is a good counterexample. It shows that this is false. Okay. I found an example where I proved that the statement is false. So that's my counterexample. Two right angles are always supplementary. So what we know about right angles is that they're 90 degrees. And if I were to put two 90-degree angles together, they would add up to 180. And to be supplementary means you add up to 180. So this is a true statement. No counterexample needed. This is true. Two right angles are supplementary to each other. They will add up to 180 degrees. Moving on. Sorry, there we go. Here we're asked to find AB. Okay. If I'm asked to find a line segment, which is what we're given here, that means to find the distance. So we're going to use our distance formula for this. We're going to use the square root of, and then x2 minus x1 squared plus y2 minus y1, also squared. And then they want us to round the answer to the nearest tenth. So we don't have to simplify anything here. We just have to get our square root, find it, and then find out its decimal form. I am going to call A, this is going to be my x1, y1. I'm going to call B my x2, y2. And then I'm just going to plug them directly into this formula. So I'm going to start with the square root of, and we're going to say x2, so 3 minus x1. x1 is negative 4. Whenever I'm subtracting a negative, we're really just adding. So plus 4 squared plus y2, so negative 1, minus y1, that's just a 1, squared. Okay, so to simplify, if I just move down here, still keeping my radical, 3 plus 4 is 7. So we have 7 squared plus negative 1 minus 1 is just negative 2. Negative 2 squared. We're going to go ahead and go up here. We have the square root of 7 squared is 49 plus negative 2 squared is 4, which becomes the square root of 53. And if I were to do the square root of 53 to get a decimal point, I'm going to say it has to be 7 something. Let's just confirm it. Yep, 7.28. And we're going to call it 7.3. Okay. So 7.3 is to the nearest tenth, because it was 7.8. Make sure if you square a negative, it comes out as a positive. If you squared it and left it as a negative, you would get the wrong answer because you would end up subtracting them, and we don't want that to happen. Okay. Now we're asked to find the middle. That's midpoint. So formula for midpoint, x1 plus x2 all over 2. And then my y value is going to be my y1 plus y2 all over 2. Because we're really just finding the average of the two of them, the center of the two of them. So if I call G my x1, y1, and I call H my x2, y2, we can say 7 plus 9, so x1, x2, all over 2. And then we could also say negative 5 plus negative 1 all over 2. And when I simplify these, 9 plus 7 is 16. So here we'll move down here. 16 over 2. And then my y value, negative 5 plus negative 1 is negative 6. And then finally, when I simplify by dividing by 2, we're going to get 8, negative 3 as my answer here for number 7. Moving on to number 8. A line segment, okay, on the coordinate plane has the endpoints, so they are giving me the endpoint A, but they are not giving me B. We're missing an endpoint. The midpoint of the segment is point M, so they have given me an endpoint and a midpoint. We are using the endpoint formula, which just tells us 2, you know what, I can actually zoom so it's a little bit easier to see. 2 times the midpoint's x minus my x1, that's my first point, and then 2 times my midpoint's y minus y1. So if I plug that in, treating A as my end point, so that'll be my x1, y1, and B as my thing that we're solving for, point M is my midpoint. So we're going to call this 2 times my midpoint's x, 2 times negative 1, minus my x1 value, which is 3. And then for my y value, we'll have 2 times my midpoint's y, which is 2, minus my y1, which is negative 5. And when I simplify these, 2 times negative 1 is negative 2 minus 3. And 2 times 2 is 4 minus negative 5. If I'm subtracting a negative, we're really just adding. So what I finally end up with is a negative 5, positive 9. And this is my midpoint. Okay, there is my solution. Lastly, what we have here, we're looking for the distance from R to T. R, if you look from the center, 1, 2, 3, 4, 5, 6, 7, 1. So R is located at 7, 1. And T is located at 1, 2, 3, 4, negative 5, 1, 2, 4, negative 5. So T is located at negative 5, negative 5. And they are talking about a location that's 5/6 of the distance. So we can think of a ratio as 5/6. Okay? And we're going to use the formula K times my x2 minus my x1 plus my x1. And we'll do the same thing for our y. K times my y2 minus my y1 plus my y1. Sorry for the overlap there. So if I just plug that in, K is 5/6. 5/6. We're talking about x2. So in this case, we're talking about R to T. So T is my 2's. These are my x2's. Okay. This is my x2, y2, which makes R my x1, y1. Okay. We're going to have negative 5 minus 7 plus my x1, 7. So there's my x value. Now for my y value, we have our K, 5/6, times my y2, which is negative 5, minus 1. And then plus 1. Okay. So there are the two things we need to solve. Let's go ahead and solve them. I'm going to start by what's in the parentheses. We have 5/6. And the only thing that's changed here is we now have a negative 12, because negative 5 minus 7 is negative 12. Okay. From here, I'm going to go ahead and multiply 5/6 times negative 12. Negative 12 times 5 is negative 60. Negative 60 divided by 6 is negative 10. So negative 10 plus 7, which is going to give me my final answer for my x value, negative 3. Okay. Here for my y value, we're going to have 5/6. Negative 5 plus negative 1, or minus 1, is just a negative 6. And then plus 1. We take care of our multiplication first. Negative 6 times 5 is negative 30. Negative 30 divided by 6 is negative 5. So we're going to have negative 5 plus 1. Negative 5 plus a positive 1 is just negative 4. Making my answer negative 3, 4. Oh, sorry, negative 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. Right there. 5/6 of the way would be right there. So that is our fractional distance. If we go ahead and move on, now we're moving on to transversals. There's a lot going on today. Here for our bundle review, looking at our angles, this is a transversal. Our red line is our transversal. Our blue line here, these are our parallels. That's what this is saying. L is parallel to M. L and M are parallel to each other. So when we think of alternate or consecutive, we're looking at the red line. When we think of interior or exterior, we're looking at the blue line. So 1 and 6 are a linear pair. They're a linear pair. Okay. I'm going to go ahead and I'm going to name them all first, and then we'll go back and talk about their relationship. 2 and 3. 2 and 3 are not in the same angle group, so we're going to look at their relationship to each other. They are on opposite sides, so they're alternate, and they are on the inside of our two blue lines here, so they're interior. So we're going to call these alternate interior, alternate, and I will accept abbreviation for space reasons. This is interior. Okay. 3 and 6. Okay. Once again, different angle groups. So we look, they're on the same side of the red line, so they're consecutive, and they're on the inside, so they are consecutive interior. Consecutive interior. 4 and 5. 4 and 5 are different angle groups. So we look, they're both on the same side of the red line, so they're consecutive, but they are both outside of our blue line, so they're exterior. So consecutive exterior. Okay. Then finally 5 and 8. 5 and 8 opposite sides, so alternate, and outside, so exterior. So alternate exterior. Uh, 2 and 4. 2 and 4, if we look, they're on the same side, so we would think consecutive, but you'll notice that one is inside our parallel and one is outside. So this is a big red flag that this is not a consecutive thing. This is corresponding, because they are both in the same position. They're both bottom right, so these are corresponding. Okay. If you'll forgive me, I just completely forgot how to spell corresponding for a second. There we go. It's 2 R's. Corresponding. Had a moment. They're corresponding angles. And then 5 and 6, they're in the same angle group, so the only option is linear pair or vertical. They are across from each other, so they are vertical. Okay. Now, if I think about whether they are congruent or supplementary, congruent means they have the same measurement. The only thing that is congruent is alternates, verticals, and correspondings. Supplementary means they add up to 180. That'll be your linear pairs and your consecutives. So here we have a linear pair. It is supplementary. So they would add up to equal 180 degrees. Here we have an alternate. Alternates are congruent. Consecutive, supplementary. Consecutive, once again, supplementary. All consecutives are supplementaries. All ulterior or alternates are congruent. So alternate, congruent. Corresponding, also congruent. They're in the same spot. They're going to match angles, like their angles are going to be the same. And then verticals are also congruent. Putting that into practice, if we look here at this transversal, they're telling me that angle 3 is 74 degrees. And I need to find every other angle. So starting with angle 1, I'm just going to do it right down the chart. Angle 3 and angle 1 are corresponding. So angle 1 is also 74 degrees. I can use angle relationships to figure everything else out from here. Angle 2 is vertical to angle 1. They're across from each other, and we just said vertical angles are congruent. So angle 2 is also 74. Angle 4 is vertical to angle 3, and it corresponds to angle 2. So those are congruent. It's also 74. Angle 5, you'll notice it has nothing vertical to it yet. We haven't solved for anything vertical to it. And it doesn't correspond with anything that we know. However, it is a linear pair with angle 1 or angle 2. So that means it adds up to 180. So if I just do 180 minus 74, we will have our totals. So 106, right? So angle 5 is 106. Angle 6 is vertical, so it is also 106. Angle 7 corresponding to angle 5. Or, sorry, hang on. Yes, corresponding to angle 5, just had a moment again. 7 and 6 are alternate to each other, so they're the same, so 106. And then angle 8 is vertical to angle 7, corresponds with angle 6, alternate exterior to angle 5. So plenty of ways to prove that it is also congruent in 106. Looking at our next problem, trying to move a little bit quicker because I did say I would have this video posted by 4:30. We have a few lines going on here. They have told us that R and S are parallel, 1 and 4 are supplementary. So they gave me that. Looking here at my blank at number 3, 1 and 5 are supplementary. They did not give me that here, so I can't use a definition because this is not a theorem. They have no relation to each other. However, if I look, angle 1 and 5, 1 and 5 are inside the parallels. They're inside the parallels. So, and they're on the same side of this here. So they are consecutive interior angles. And if I look at my answer choices here, we have consecutive interior angles. So number 3, I could say is a consecutive interior angle. Okay. Looking at number 13, we want to figure out number 5. So once again, if I look at my blank, number 4 is talking about it being supplementary. That's a word that we're using to describe what's going on. And number 5 is adding those together to equal 180. That's a number that we're using to describe. Remember whenever I told you that we compare words to numbers, we're looking at definitions, and the definition is always in the name. So it is a definition of supplementary angles. It is the definition, and I'm just going to abbreviate, of supplementary angles. Okay? It's the definition of supplementary angles. Looking at number 14, we did this one in class together, but I still want to discuss it again. They are telling me that NM is an angle bisector. I know the picture might not look like this, but MN is clearly bisecting LMO. So that means that this angle and this angle are congruent to each other. Then they tell us LMO is equal to OMP. This larger angle here is equal to this angle, the 90 degrees. So that means this one is also 90. If this is a bisector, they are cutting that 90 in half. So we know that each of these angles is 45 degrees. We also know, because these are 90, that this must also be 90, and so must this. So using all of that information, we're going to read here to see if we can find some conclusions that are valid, that can be true. LMN is 45. LMN, that's this angle, and we've already established that is true. OMN, so that is my smaller angle, OMN, that's the 45 here, and OMP are supplementary. Remember, to be supplementary, you have to add up to 180. If this is 90 and this is 45, they do not add up to 180, so these are not supplementary. QML is 180. QML, we just established this is 90, so that's not true. And then LMN and OMN are complementary. LMN, it's 45, and OMN, it's 45, are complementary. And complementary means that we add up to 90. 45 plus 45 is indeed 90, so that is true. Now, looking at this construction, we see, we've talked about this. This is an angle bisector. It is cutting our angle in two. So this is congruent to this. So if I compare them, ABD is my smaller angle. It would not be half of CBD, my other smaller angle. They would be equal, which I see right here. ABD is equal to CBD. Those are my two smaller angles. They're equal to each other. Okay. If I check my other choices, ABD is my smaller, ABC is my larger angle. So ABD and ABC are not the same. ABD is half of ABC. CBD, that is one of my smaller angles, is equal to half of ABD, which again is one of my smaller angles. So B has to be the correct answer here. We discussed constructions and how to spot a perpendicular bisector. What we're going to see is overlapping curves here. Those overlapping curves are telling me that we're looking at where the line segment is crossing through. This is a perpendicular bisector, okay? And then in closing, if I seem rushed, I do apologize. It is 4:26, and I told you guys that I would have this posted for you at 4:30. So I just want to get this done as soon as possible. If the lines are parallel, perpendicular, or neither, that is what we need to discuss. So if they are already in slope-intercept form, all we're looking is the slope. M equals 3. M equals negative 1/3. Okay, so they're parallel, they would be the same. If they're perpendicular, that means I could take the 3, flip it, so it would become 1/3, and then change the sign. So that is the case here. So this is perpendicular. Number 13 is perpendicular. Number 14, my slope, M equals 2. M equals 2. Same slope, nothing to solve here. They are parallel to each other. They are parallel. And then y equals 2. There isn't an x value here. So this is what we call a zero slope. M equals 0. And x equals 3. This does not even have a y value. This is what we call an undefined slope. Undefined. If I were to graph these, I would have y equals 2 would just be a horizontal line, okay? And an undefined line would just be a vertical line. Those are parallel to each other. Or not parallel, perpendicular. My apologies. Those are perpendicular to each other. Okay, a zero slope is perpendicular to an undefined slope. The last things that we're asked to do is create lines that are either perpendicular or parallel. All we're doing is writing something in point slope form and then solving for y. So here we are. Point slope form is y minus y1 is equal to m, my slope, times x minus x1. Okay, we want something that's perpendicular. So we want something that's perpendicular to this slope. So negative 1/4, if I flip it and change the sign, becomes 4. So my m equals 4, and the point that I'm passing through, my x1, y1, is right here, negative 2, negative 11. So I'm going to plug those in. I'm going to have y minus negative 11, so y plus 11, because if we subtract a negative, we're just adding it, equals, my slope is 4, and then x minus negative 2, so just plus 2. I'm going to distribute, because we have to get rid of parentheses first. I'm going to distribute and multiply everything on the inside, and I will get y plus 11 equals 4x plus 8, because I distributed. Now I'm going to subtract 11 from both sides, because we do the opposite. And when I do that, we are going to end up with y equals 4x, and then 8 minus 11 is negative 3. So there is our equation for a line that's perpendicular and passes through this point. Parallel means same slope. So my m is negative 2 over 3, and my points right here, y2 or y1. Okay, so when I write this, I'm going to say y minus y1, so y plus 1, because it's a negative, equals my slope, negative 2 over 3, x minus my x1 is negative 6, so plus 6, because it's negative, so we just put the opposite. I'm going to distribute, so we end up with y plus 1 equals, and when I distribute this, we're going to have negative 2/3 x, and then 6 times negative 2 is negative 12, divided by 3 is negative 4. And then finally, I'm just going to subtract 1 from both sides, so we get y equals negative 2/3 x, and since I'm subtracting 1, minus 5. And there is my other equation for number 19. This is my equation. It is parallel because it has the same slope. Remember, parallel lines have the same slope. Perpendiculars have the negative reciprocal. We're taking the opposite sign and we're flipping them. Okay? So, 432. It's not the best. I did tell y'all 430. I do apologize for that. I'm going to upload this to YouTube right now. I am going to have it posted. That way y'all can watch it. You can fill out your reviews to make sure you have it complete. You can check your answers, check your work. Make sure to study over this, and I will see you all tomorrow ready to tackle this. Have a good night.